Now we are going to the overview of this patch antenna which we created earlier. First we have to assign variables or create the variables by using symbol hash from the keyboard, or simply double clicking on the variables. We will get a pop-up window that create variable. We can add and create the variables. We should type here and we should type the expression and we should create the variables. These are the variables should be created here. They are showing these are the variables should be created from A to ZF0. And after creating these variables we will get the geometry part, that is this part will be created which is showing phase 9. This will be created after this part is created. We should take a polygon command. I already took the polygon, so I will show you the values or the properties of the polygon. See, this is the polygon. This is the polygon, the properties of the polygon, and we have to declare these properties. That is, this is the corner one. We are having 8 corners, so this is the corner 1. You can observe here when I am clicking on the corners, it will show the corner point. This is the corner 2, corner 3, corner 4, and corner 5, corner 6, corner 7, and lastly corner 8. These are the corners to create a polygon. Then next we have to make this as, take this as, we have to go to media, double click on media. We will get a window like this, a pop-up window like this. Here we have to change this relative permittivity, that is ER, to 3.4. that is the dielectric material. I already created here, so see my dielectric permittivity or relative permittivity will be 3.4. After creating this, take a cuboid under surfaces, under construction, under create solid surfaces. We are having cuboid, take cuboid, or simply we can use C and 1 command from the keyboard. C and 1 keys from keyboard. We can use Control and Shift to move this cuboid or any surfaces. And I already designed cuboid, so I will show you the cuboid values, properties of the cuboid. And this is the width, and this is the depth, this is the height. We have to add -2e -3 for the value which we have dragged, and place 2e -3, and the height will be the height of the substrate which we declared in variables. This cuboid will be overlaid on this phase 9 surface. Next we have to use copy and mirror command for this. After creating a cuboid, we use copy and mirror command. Here we are having copy and mirror command. Under transforms we are having copy, click on it, and we are having copy and mirror command, click on it, and here we are having the mirror plane and work plane. We should click on V and N plane. This is the opposite plane of UV plane. So now our surface is on, this will be on UV plane, so we should create them in VN plane. That's why we are selecting that. After that we will get this plane, the selected surfaces, and then we have to create an edge port. For that we have to create a rectangle. This is the rectangle one. This is the rectangle. This is the rectangle. Let me delete it for you. I will show it clearly. See, this is the rectangle should be created. This is the rectangle should be created. The properties of this rectangle will be rectangle 1, and this is the U coordinates. We can directly use and drag by using Control and Shift commands, and place it over here and here, here to here, or simply take a line command. Under construct, take a line command and use Control and Shift, keep it here and drag it for here. See, that is starting point is 0.00184 and the ending point will be starting point and ending point, it will be 0.00184. so we can use that also. You can use that method also, that is, see here, -0.00184, right? So the width of the rectangle will be W50, which we declared in variables, and depth will be height of the substrate. This is known as height of the substrate. Here this black color part will be the height of the substrate, or simply we can say practically that is thickness. And after creating this rectangle, we should select this rectangle, and by going to transform, copy, and we should copy and translate use copy and translate command. I already used, so it is disabled. You can click on copy and translate, and using control and shift commands, this will be moved to here. You will be specified some points, make it at the middle point, so that we will be created this point. And another rectangle is used to cover these two rectangles, that is like this. The rectangle should be covered. We'll show you. The rectangle should be covered by these two rectangles, and on this rectangle surface we will create an edge board. For that, we have to split this rectangle first, and we have to union it by using, here we have union, and this is the split, and this is the separate, and this is the intersection. We use union and split commands. That is, we have to split it. I already split it, so I will show you the splitted part. This is the one split part, and this is the another split part. After splitting, we have to select these both. And we have to click on union. Already I union, so it is not showing, it is disabled. After union of these two, we have to select this union part, and here we are having faces. Here we are having faces 3, 1 and 3, 2. Click on control, and with the mouse keys select these two, and click on right click. Then we are having create a port. Then we have to go to edge port, and here we are having two faces, and we have to select the edge ports as, here we are having red and blue lines for this. See, here we are having red and blue line. The blue line should be come to the bottom, and the red line should be at the top, so that you should select the faces. See it and select the faces while creating the edge port. After creating the edge port, function F5 command is used to zoom to the full extent or full view of the design which we designed. Next, after this, after the created of faces, and the edge port will be created. Then if we enable automatic meshing, the meshes will be automatically provided, or if we not enable automatic meshing, then we have to create mesh, and click on create mesh and mesh. I already measured, so this is the mesh will be created. And now the most important part, the bottom part of this material or the plane will be created as PEC, because when we made it as PEC, then only it will work as ground plane. So here click on this part. This part is selected, right click, then we are having properties, right click, go to properties. Here we are having medium. Initially it will be default, you made it to perfect electric conductor, that is PEC, and similarly for the other part too, this will be also made as PEC. Then we have to make these three also, these three rectangles, that rectangle 1 and this rectangle should be made as PEC. This rectangle and this rectangle and this rectangle should be made as PEC. If not, our mesh will be not correct. The produced mesh will be causes errors. After this, union all the geometry part by selecting all by using the control or shift command. You can use any one, control or shift. Select all from this union part. From this union part. And now click on union, that will be under constructions. Here we are having union all the parts, and the mesh will be provided according to it. When we enable automatic meshing, under meshes we have to enable automatic meshing, or we can simply enable from here. We are having at the bottom. After this, our antenna will be ready, and we have to go to solver run, then click on FEKO solver. Sorry, I forgot to say you, under configurations, or click on source and load. We have to add a voltage source. I forgot to tell you, that is the main part. We have to add a voltage source. I already added. We have to add a voltage source like this. Here we are having edge port 1, near the edge port 1. This is the voltage source 2 because I added already voltage source 1, so it is showing voltage source 2. At the edge port we are having the voltage source, and then we have to add the frequencies, clicking on the frequency, and here it is initially taking as single frequency. You should make it to linear spaced discrete points, which means we can declare the frequency points, that is fmin and fmax, which we declared at the starting of the design in the variables. This is the fmin and this is the fmin and this is the fmax, and the number of frequencies should be specified. Then click on OK. Before running it, you have to make sure that the far field request, go to far fields, and here we have to make it as 3D. I already had one, so when we make it 3D, it will create another. See, like this. This is the 3D far fields 3D view, and here this is the main part to design, to analyze this antenna under WinProp. In WinProp we want the ASCII file, that is .ff file, that is far fields file. We have to click on export this and add and create it. So this is the far fields. Similarly, we want this out file and this .os file also, so click on export and add and create. Then we go to solve and run. We use FEKO solver. Click on FEKO solver. This model is already exists, so click on OK. It will be run initially. This is the design. It will take some time, so let us go to directly. After requesting the file, we can run the FEKO solver, and we can see the results in post FEKO further. For the FEKO solver running and solving the results. This is the post FEKO results where we are having copies on that, and click on partition. This is the reflection position and the reflection. This is the reflection coefficient, and this reflection coefficient must be less than 10 dBs. Go to dB and it should be less than 10 dB, which means we got the correct reflection coefficient. And we can observe the far fields by dragging this into here. These are the far fields, and we can vary the frequency here up to 7 GHz, and we can observe the currents here. Click and drag the currents into it. So these are the currents, and this is the scale for that.